is the 9th video dedicated to Bessey shuffle diagrams. As a reminder, a shuffle S is said to be a Bessey shuffle if and only if S preserves or inverts Bessey sequences. Recall, the Bessey sequences of order 8 are 1, 0, 0, 1, 0, 1, 1, 0, and its inversion 0, 1, 1, 0, 1, 0, 0, 1. Also, recall that the two sets of position values of importance to us are the following. Positions 1, 4, 6, 7, which we will color code black, and positions 2, 3, 5, 8, which we will color code red. When cards that begin in positions 1, 4, 6, 7 end up in these same positions after a shuffle is completed, and the same thing for 2, 3, 5, 8, if the cards within these positions stay within those positions, then we say that that Bessey sequence is preserved, and it's denoted as follows. On the other hand, if the cards that began in positions 1, 4, 6, 7 move to positions 2, 3, 5, 8 in some assignment, then we say an inversion of the sequence has occurred, and we represent it this way. Finally, recall that our Bessey sequences 1, 0, 0, 1, 0, 1, 1, 0, and 0, 1, 1, 0, 1, 0, 0, 1 each satisfy one or the other of these two cases here. So in the first case here, the ones are in positions 1, 4, 6, 7, and the zeros are in positions 2, 3, 5, 8. For the inversion of this sequence, the role of zeros and ones switch places. Today we have 4 special shuffles in the study of cyclic and mirrored structures. The first one is called an alternate Klondike, and we will be stacking the left pile on top of the right. So let me go ahead and demonstrate this shuffle. As always, we begin with our ordered packet 1 through 8, and we perform our shuffle, and then we take a look at the new ordering. So what is an alternate Klondike? Well, this is where you hold the cards in biddle grip, it's called, and then you perform a Klondike shuffle type action. So you pull off the top and bottom card as 1, you set it down into a left pile, and then you take the top and bottom card off as 1 and set those two into a right pile. Top and bottom off as 1 into the left pile, and then the remaining 2 cards get set onto the right pile. And since we are stacking left on right, we will get the following new ordering. We get 3, 6, 1, 8, 4, 5, 2, 7. Expressing this outcome in Cauchy's 2-line notation, we obtain the following. The top row, as always, is numbered 1 through 8, and the bottom row is 3, 6, 1, 8, 4, 5, 2, 7. Converting this to cycle notation, we obtain the following. We see that 1 goes to 3, so we have an arrow from 1 to 3. 3 goes back to 1, so we have an arrow returning to 1. So this constitutes a 2 cycle, also called a transposition. Those two just switch places. Next, we see that 2 goes to 6. We have an arrow from 2 to 6. 6 goes to 5. There we go. 5 goes to 4. So we have an arrow from 5 to 4. 4 goes to 8. There we go there. And 8 goes to 7. And we have an arrow from 8 to 7. And then 7 returns back to 2. So it cycles around, giving us a 6 cycle. Color coding our numerals, we obtain the following. Recall position values 1, 4, 6, 7 are color-coded black, and position values 2, 3, 5, 8 are color-coded red. So we see that black 1 goes to red 3, which returns to black 1. Red 2 goes to black 6, which goes to red 5, which goes to black 4, which goes to red 8, which goes to black 7, which cycles around to red 2. So we see that each value gets sent to a value of the opposite color. And when this happens, inversion has occurred. Consequently, if we use our quintessential Bessey sequence 10010110 and perform the alternate Klondike, in which the left pile is stacked on top of the right, it should invert this sequence. So why don't we go ahead and check that. So remember the alternate Klondike, you're pulling the top and bottom off as 1, setting that down on the left, top and bottom off as 1 on the right, top and bottom as 1 on the left, and the final 2 go on the right. We're stacking left on right, like so. So do we get the inversion of that original Bessey sequence? Well, we do indeed. We get 0, 1, 1, 0, 1, 0, 0, 1. Now, it is important to note that all of the cards here have moved from their original locations, right? So, for example, we know that the card originally in position 1 and the card originally in position 3 have switched places. So essentially, that card label 0 used to be where this one is right here. And that card right there with the 1 used to be on top. And a similar kind of thing is happening with all of the other cards. They are genuinely being moved around in such a way that 1s and 0s switch places. Also note that this shuffle is of order 6, since we have a 2 cycle and also a 6 cycle. So it would require performing this shuffle 6 times to return the packet to its original order. Let's go ahead and take a look at the shuffle diagram for this shuffle. So top row on the left, we get the following. And as you can see, it's quite a messy looking shuffle here. So we know that 1 and 3 switch places. So what that means then is we should have a double arrow from 1 to 3, and we do. Now look at what 2 does. 2 goes to 6, which goes to 5, and then to 4, and then to 8, and then to 7, and then back to 2. So if we begin at 2, we go down to 6, and then down here on the right to 5, straight across to 4, up here to 8, down to the left to 7, and then straight across to 2, completing that cycle. So that is our 6th cycle, and we say that the values 2, 6, 5, 4, 8, 7 constitute an orbit, which simply means they move around among themselves, and also the values 1 and 3 form their own orbit. Now, I have something here on the top left that we have not seen before. So if you have studied the Hidden Structures online course, you'll be familiar with the following diagram. So let me just go ahead and draw it. So let's say we have 2C. That stands for 2 cycles. And this is cycle with a capital C. So these are 2 cycles in the study of cyclic and mirrored structures. M is for mirrored. And then we have A, M, P. Stands for adjacent mirrored pairs. And then there is an arrow from there up to 2 cycles. So what I am pointing out for all 4 shuffles today is that the alternate Klondike, in the case of 4N, cards or 4 and objects. So in other words, we're talking like 4, 8, 12, 16, and 20, etc. The alternate Klondike in all 4 of these cases today will convert a 2-cycle structure, as studied in the Hidden Structures online course, to mirrored structures, and these same alternate Klondike shuffles will convert mirrored structures to AMP structures, and they will also convert AMP structures to 2-cycle structures. Now, I do want to emphasize that this is extremely rare, that you can find a single shuffle that will convert between all 3 structure types. It just cycles around. That rarely happens. So in that sense, the alternate Klondike is a very special shuffle.